We are learning about roots of quadratic equations, but first let's go ahead and review graphing quadratic equations. When I have one like y equals x squared plus 4x minus 5, we can begin graphing that by first finding the axis of symmetry. So the formula for axis of symmetry is x is equal to negative b over 2a. So b is 4. And then a is a positive 1. And so that gives us x is equal to negative 2. Once we know x is equal to negative 2, we can find the vertex. All we have to do is substitute that into the original equation. So we're going to have y is equal to negative 2 squared plus 4 times negative 2 minus 5. So our vertex is negative 2, negative 9. Negative 2, negative 9. And if we want to be able to fill in the rest of our values, all we have to do is substitute the values of negative 3, negative 4, negative 5, and then negative 1, 0, and 1 into our equation to figure out what y is equal at those points. I went ahead and did that already, and so I'm going to go ahead and graph the points. So this is the graph of y equals x squared plus 4x minus 5. This is a line that curves and it continues to go up and it continues to go outward. One of the things I want you to notice when we're looking at this curve is that if you know the vertex, because your A is 1, it follows the basic pattern, which means that from the vertex to the next point, it only moves 1, and then it moves 3, 5, and then 7. So it's basically an odd number, just like the spacing between perfect squares. So now that we have graphed this one, we're going to go ahead and graph the other two equations, but I have already come up with what the table of values are, and we're just going to plot those values. So my vertex is 1, 0. And this graph also curves upward. And then on this one, because it has a negative 1 as your A, we know that this parabola is going to curve downward. On this one, my vertex is 1, negative 2. And this graph is curving downward. Now, one of the characteristics that we often like to look at when it comes to parabolas is where it crosses the x-axis. We call those x-intercepts, where it crosses the x-axis. So on this one, it crosses at negative 5 and positive 1. On this one, there's only one x-intercept, and it crosses the x-axis at 1. Anytime you have a vertex that's sitting right on the x-axis, you're only going to have one x-intercept. And then notice this one, it never crosses the x-intercept, the x-axis at all, And so therefore, there are no x-intercepts. We have several words that we use to talk about that. We not only say x-intercepts, but we also call them roots, solutions, and we call them zeros of the function.